All right, guys. We're going to take a look at logarithm laws as promised. Many of you said that you'd already seen these before. So hopefully you'll also like the way the IB presents them. Here are the first set of laws we're going to look at. There's only one more, the change of base, I'm going to add in just a minute. You have these in your formula booklet. Do be very careful with where is being multiplied, where is being added. Okay, it's not inside. You'll see that there's a lot of similarities here because they are just like, for example, addition and subtraction, opposite operations, very similar, if not the same in some ways. Whereas exponent laws, for example, add inside and separate into multiplication. Because logarithms are the inverse, they multiply inside and add when they're separate. Same all the way down. Pause this, write them down, take a look at your formula booklet, compare the identities and laws. Make sure you have them as I go on then. Here are some pretty simple ones. Using those laws, which hopefully you have in front of you now because I'm just going to use them. Write as one logarithm and then simplify if possible. Important is that they have the same base, which all of these do, 3, 10, 10. And when they're separated into addition, they come together as multiplication. Okay, so log base 3 of 60. And I can simplify this a little bit because there is a power of 3 that is inside 60 if I multiply it out. Remember, I can separate it into multiplication here, so that's 3 times 20. 9, 27, etc. are not in 60. And that will then come together. I'm going to go to the next line. I'll separate out really. Log base 3 of 3 plus log base 3 of 20. And this is saying 3 to the what is 3? Well, 1. So log, that can't be simplified at all. The next one, log of 400 minus log of 4. That separated subtraction can come together as division. That's log base 10 of 100. And this is asking us 10 to the what is 100, 10 to the 2 is 100. That one's a nice simple one, which we wouldn't have seen if we didn't have those properties. This one, remember that this multiplication separate comes together as a power. So this is log of 7 squared, log 2 to the 4th, or log of 49, and log of 16. Those can come together as multiplication. Not a, oops, that's a 9, apologize. Not a really nice one, but 50 times 16 is 800, and I can take away one of those 16s, and 800 minus 16 will be 784. Ooh. Log of 784. There's no way I can separate any powers of 10 into that without making decimals or making that more messy. This is a very IB style question, kind of getting you to simplify it in terms of other variables. What we're going to do is we're going to look and see how these different numbers can be written as 3s and 6s using those laws, being careful to avoid addition, subtraction, etc. in the wrong way. So log base 10 of 18. Well, using 3 and 6, 18 is 3 times 6. Okay, so I can separate this multiplication as addition. And now that I have these things completely separate, log of 3 is x according to this problem, and log of 6 is y. And that's what they're going to try to see. Does it have that addition? Are you separating this out correctly? Same thing here. How are 3 and 6 going to form 36? You don't necessarily need to use both in these problems. That's 6 squared. And important, it's not log of 6 squared, it's log of 6 squared. If you understand the distinction, that 2 has to come in front before we can separate it. This is really one piece here that can't be separated for that. But now it can. That's 2y. Same here. Hopefully it jumps out at you that 3 divided by 6 is a half. Using those same numbers, so I have the ability to separate that as subtraction, or making sure now we have the right order. That's important, x minus y. And this one is going to be the next one. We're going to come back. I just didn't want to have to write this again. Okay, this is a change of base because you see here this is a base 10 and this is going to be a base 3. So we'll have to take a look at that in just a second. Here's a similar question, but a little bit more challenging. Very common to have these. I need to use many different laws to separate this into its pieces and then write that as x and y without a log. So log base 5 of p to the 4th over the square root of q. You need to make sure you're separating this in the right order. It should kind of jump out at you that we can't just take like the square root out first because it's just in the denominator on the q. So first I'm going to undo this fraction here. And that's division, so I can say, well, that's p to the 4th, and then minus log base 5, square root of q. And it will now be important to remember that the square root is q to the half, using, again, the same laws we've had before. So that's 4 log base 5s of p, and a half log base 5 of q. And now these are broken down enough where I can call this is x, and this is y. So that's 4y minus 1/2, 4x minus 1/2 y. Okay. This also works with ln. It works with any base. You might have been able to do these problems too before when you were just recognizing exponent laws. Pretty simple to do that way. Here's another way of thinking of those. That's e to the half. We can pull that half around. And remember ln of e, because it's log base e of e, it's just one of the identities. That's a half times 1, or half. Okay, same thing here. We can separate this. If you didn't want to use the laws, it looks like my pen is giving up the ghost, as they say. Separate, plus, because it's multiplication. Pull around those exponents. Plus y ln of e. Hopefully I can make it through with this pen. And then again, recognizing the properties of logarithms there, the identity. Pretty simple if you're comfortable with them. Always use your formula booklet. And now the last law, also in your formula booklet, you can turn any logarithm with any base into a logarithm with a new base, which is useful if you have a calculator, for example, that doesn't let you pick whatever base you want. You could turn it into base 10 or ln. It's also nice to kind of simplify some of these into less things. So in some way, you kind of can take something with division and put it into this form, make it a little bit nicer looking depending on what it is. Here are some pretty simple examples, just seeing where these go. You'll see here that if you look at the original law, the base goes on the bottom as the argument, and the old argument goes on the top as the argument, the denominator and numerator, picking whatever base you want. So if I want to write this as a base 10, just plain log, I could say, well, this goes on top. The 8, the argument is the numerator's argument, and that base is the denominator's argument. Done. Same goes the other way. This is base E, but it doesn't matter because I lose the original base as long as they match. So the bottom one is base and the top one is the argument. Taking a look at this pretty simple one again, coming back to all this. Here I could use this change of base. It says I want to have it as base 10. So log, I could have done whatever they have here. The bottom one is bottom, top one is the top. That's going to be y over x. Okay. And finally, a nice IB one here, a change of base. I see that I want change of base formula because my base is changing, then it's going straight to that in my mind. Given that log base 5 of x, express, so we're going to start with this, log base 25 of x in terms of y. So I want it to end up with a base 5, and I need the same base in the numerator and the denominator. The argument goes on top, the base goes on bottom. Well, this is what they said is y, and this is 2, because logarithms ask us what's the exponent that takes 5 to 25. 5 squared is 25. So now we have this expression written as in terms of y, or half a y is also fine.